Hello dear students, welcome to my physics channel Physics R&T. I am Ramesh Narayan Tripathi. We will study some more multiple choice questions on acceleration due to gravity. The first question is the imaginary angular velocity of earth for which effective acceleration due to gravity at equator will be 0 is equal to, these are the options. So, solution to question 1. We know at latitude lambda, acceleration due to gravity g dash is equal to g minus r omega square cos square lambda. At equator lambda is 0. In this case, at equator acceleration due to gravity is to be 0. So, this equation gives 0 is equal to g minus r omega dash square cos square 0 because latitude at equator is 0. So, it becomes g minus r omega dash square is equal to 0, which gives omega dash as under root g by r. Omega dash is equal to 9.8 upon 6.4 into 10 to power 6, which gives 1.24 into 10 to minus 3 radian per second. Thus, the correct option will be A. Now, second question. Speed of Earth's rotation about its axis is omega. Its speed is increased to x times to make effective acceleration due to gravity 0 at equator. Then the value of x is. Solution to question 2. At latitude lambda, g dash is equal to g minus r omega square cos square omega. G dash is 0. Therefore, 0 will be equal to g minus r omega dash square cos square 0, which gives omega dash as under root g upon r. Omega dash will be equal to under root 9.8 upon 6.4 into 10 to power 6, which gives 1.24 into 10 to power minus 3 radian per second. Now, omega dash upon omega is 1.24 into 10 to minus 3 upon original omega is 2 pi by t, time period of rotation of earth, which is 86,400, which gives 17.05, which is nearly 17, hence the correct option will be B. Next question number 3. If earth rotates faster than its present speed, the weight of an object will. These are the options. Solution to question 3. Again, at latitude lambda, acceleration due to gravity g dash is equal to g minus r omega square cos square lambda. At equator, lambda is 0. Therefore, g dash will be equal to g minus r omega square. And at pole, lambda is equal to 90 degree. Therefore, g dash at pole will be equal to g minus r omega square cos square 90 degree, which is 0. So, g. Thus, the acceleration due to gravity will decrease at equator but will remain constant at pole. So the correct option will be A. Next question number 4. The question is, taking the radius of Earth 6400 km, by what percentage acceleration due to gravity at a height 100 km above Earth's surface differ from that on the surface of Earth? So solution to question 4. Delta G upon G into 100% will be equal to 2h upon R. Here it is 2 into 100 km upon 6400 km. Kilometer cancels out and we get 1 upon 32, which is 0.03, which can be written as 3%. So the correct option will be B. Next question number 5. The question is, weight of a body of mass m decreases by 1% when taken to a height h above Earth's surface. The change in weight when taken to a mine of depth h below Earth's surface will be. These are the options. Now, solution to question 5. Delta G upon G into 100% with height h above Earth's surface is 2h upon R, and this is 1%. Therefore, delta G upon G into 100% below height, below depth h will be equal to h upon R, which will be 1 by 2 of 2h upon R, that is 1 by 2 into 1%, that will be 0.5%. So the correct option will be B, 0.5% decrease. Next question number 6. The question is, the height vertically above Earth's surface where the acceleration due to gravity becomes 1% that are at the Earth's surface, where R is radius of Earth is. These are the options. So solution to question 6. Here G above Earth's surface upon G on Earth's surface is given to be 1 upon 100, 1%, which can be written as G m upon R plus h square divided by G m upon R square. Gm gets cancelled and it gives R upon R plus h whole square. So taking square root on both sides, we get 1 upon 10 is equal to R upon R plus h, which gives 10 R is equal to R plus h. Hence, h will be equal to 10 R minus R means 9 R. So the correct option will be A. Next question number 7. The question is, at what depth below Earth's surface acceleration due to gravity becomes half to that at a height 1600 km above Earth's surface? These are the options. solution to question 7. According to question, we have G with depth D is equal to 1 by 2 G with height H. Therefore, small g 1 minus D upon R will be equal to 1 by 2 G M upon R plus H whole square. This can be written as 1 by 2 Gm can be written as G R square upon R plus H whole square. In this equation, G cancels out and we get 1 minus D upon R is equal to 1 by 2 R upon R plus H whole square, which can be written as 1 minus D upon R is equal to 1 by 2 R is 1600 kilometer upon R plus H is 8000 kilometer its square. This can be written as 1 by 2 into 16 upon 25, that is 8 upon 25. Thus 1 minus 8 upon 25 will give D upon R, which is equal to 25 minus 8 upon 25, that is 17 upon 25, which gives D as 17 upon 25 into R. R is 6400 kilometer. Hence, D comes to be, which gives D as 4352 kilometers, which can be written as 4.35 into 10 to the power 6 meters. So, B is correct option. Next question number 8. The question is, at what height from Earth's surface gravitational potential and acceleration due to gravity have values minus 5.4 into 10 to the power 7 joule per kg and 6 meter per second square respectively. Take the radius of Earth as 6400 kilometer. These are the options. So, solution to question 8. At height h, from Earth's surface, gravitational potential is V is equal to minus Gm upon R plus H, and acceleration due to gravity is G dash is equal to Gm upon R plus H square. Therefore, numerically V upon G dash will be equal to Gm cancels out, R plus H whole square upon R plus H, which is R plus H. Therefore, V upon H will be 5.4 into 10 to the power 7 upon 6 is equal to R plus H. Therefore, R plus H will be equal to 9 into 10 to the power 6 meter, which is 9000 kilometer. Therefore, H will be equal to 9000 minus capital R 9,000 minus 6,400 kilometer means 2,600 kilometer. So the correct option will be D.